Welcome to the CIDCI online Salon series. I'm Zig Rubel, CIDC board member and treasurer. On behalf of the CIDCI Board of Directors, I'd like to welcome you here today. Margie O'Driscoll, who normally facilitates these sessions, is away today. She will be back for our next Salon. CIDCI's mission is to accelerate innovation, disruption, and change to improve the built environment. We create networks that share knowledge, experience, and ideas through productive dialogue. CIDCI is a not-for-profit organization that relies on financial support to provide these programs. Thank you to our sponsors who make all of this possible. CIDCI recently started our Innovation Lab, and it's not too late to enroll. Led by UC Berkeley's Sarah Beckman and Rachel Zombach, this online program uses a self-paced format to create a community of practice within the AEC community. This 6-module program will teach participants the mindset and skill sets associated with the innovation process. The content for these modules will all be delivered asynchronously via Google Classroom and will include videos, readings, and discussions for questions. Participants can access the material at any time during the 2021 session. Details are available on the CIDCI website. If you see something you want to share with a client or friend, feel free to direct them to the CIDCI website to hear recordings of these events. Here's a bit of information for today's session and how it will work. We are recording this presentation and we'll place it on the CIDC website as soon as possible. If you have questions or comments during the session, please use the chat box. Today's session will run for 60 minutes. Today, we will explore when buildings design themselves. What if they did? How might architecture evolve if computers took over the design and construction process? Presenting is Lance Hosey, FAIA Lead Fellow. He is the Chief Impact Officer at HMC, where he oversees design, sustainability, communications, and research. He has led the design of many award-winning high-performance projects and has written 2 books and hundreds of essays on design, innovation for the New York Times, the Washington Post, the Huffington Post, and many other publications. Lance will be in conversation with Dr. Semiha Ergan, CIDC board member and faculty member at the Department of Civil and Urban Engineering and Computer Science and Engineering at New York University. Her background in civil engineering, data science, and building informatics enables her to work on improving buildings' performance during design, construction, and operations. Lance and Semiha, we are delighted to have you join us. Lance, please get us started.
Thanks, Zig. Thank you all for having me. I'm going to jump right in just because I tend to be kind of chatty, and I want to make sure that we get through all this. So thanks, Zig. As Zig mentioned, I'm Chief Impact Officer at HMC. If you're not familiar with HMC, we were founded in 1940. With an explicit mission to serve communities. So for 80 years, we have worked exclusively in markets that have some connection to the larger community: education, healthcare, civic, etc. I joined last year as Chief Impact Officer. We think I'm the first person in the design industry to have that title. And I essentially oversee our mission to all of our activities to make sure that we're fulfilling our mission to have a positive impact on communities. I think that's relevant to today's talk. And I'm going to dive into that by pointing out that you may have seen in recent years, there's an increasing number of headlines that look something like this, that robots are coming to take your job. This list of on the left of logos is just a slice of the number of major media outlets that have had some version of this, that the robot takeover is coming anytime. The most widely cited study on this, automation and how it's going to affect different industries, from Oxford University, estimates that by 2033, so within the next decade and a half, a little more than a decade, nearly half of all jobs will be automated. So virtually, half of all jobs are at risk of being automated. The ones that are most likely to be replaced are telemarketers. The reason you're getting an increasing onslaught of robocalls is because that's a very easy thing to automate. The job least likely to be automated is something called a recreational therapist. I don't know what that is, which is essentially why it's hard to automate. As that study said, if your job can be easily explained, it can be automated. No one seems to know what a recreational therapist is, so it's not at risk of being replaced by robots. So if you look at the AEC industry, construction, the odds are of jobs being automated within the construction field about 88%, so very high. This is why you're seeing a lot of articles in recent years about bricklaying robots and other machinery that can take over manual labor much more cost effectively, efficiently, higher productivity, because it's very repetitive labor. My friend Scott Howe at the NASA Jet Propulsion Laboratory says there will come a day when no human labor is present on any construction site. You might see little drones delivering bricks, etc. Now, if you look at the design side of the AEC industry, architecture, there, according to this study, there's a much lower risk of being replaced by robots, less than 2%. Now, this was 8 years ago when this came out, but today there's actually a website you can go to with the great name willrobotstakemyjob.com, and you can enter any job and it will tell you what the risk of being automated is. I like this little list below because apparently accountants and lawyers and computer programmers are among the people with the most anxiety about whether they're going to be replaced. Lawyers kind of surprises me a little bit. When you look at architects, it says the same thing, less than 2%. So over the last decade, the likelihood of being automated, of architecture being automated, hasn't really changed much. So they label the risk of automation among architects as totally safe. So this kind of thing led me to do a fair amount of research and writing around this basic question of whether machines can design. And I'm really less interested in the technology of this because technology is changing all the time. I'm really more interested in the hypothetical question is, well, what if machines could replace our job? What if that 1.8% became 100%? What would be the implications for our industry? And it leads to a question of, well, if we're asking whether machines can design, then we really need to understand what design is in general to know whether machines are capable of it. More specifically, what is good design? Because if humans or machines do it, presumably we want them to do it well. Here's a question that Gary Hamel, who's a business thinker the Wall Street Journal calls the most important business thinker in America today, says that good design is like the Supreme Court's definition of pornography. We know it when we see it. And when you look at our own industry, the AIA is really not much more specific about this. 9 years ago, there was a 3-day conference that the Committee on Design put together to ask this question, defining design excellence. If you read the report, it essentially says that there are lots of provocative observations, no consensus. So what is good design? We generally don't have a consensus about that. I think that's a problem. I mean, how are we meant to practice good design if we can't say clearly what it is? So you see lots of articles, if you apply this back to the question of whether machines can design, if we can't say what good design is, then how can we say whether whether machines are capable of doing it. I think this is one of the subtler reasons why there are lots of experts who say that it's impossible to get computers to think creatively in this way. And yet, a decade ago, people thought that robots couldn't dance, and today we have lots of examples of that. So the thinking around this is changing all the time. Kevin Kelly, who's a co-founder of Wired, wrote an amazing book called What Technology Wants. And he says explicitly, robot replacement is just a matter of time. Doesn't matter if you're a doctor, lawyer, architect, reporter, or even programmer. He specifically lists architects as being susceptible to this, if you think of it as a risk or a benefit, that it's only a matter of time before it happens. And in fact, we see if the basic question, as Daniel Davis said it in that article, he used to be the lead researcher at AutoCAD, I believe. Autodesk, sorry. If the basic question is whether computers are capable of creativity, there's lots of research from experts who say that the coming creativity explosion is actually with artificial creativity. So this is a whole new field of study. And you see lots of examples of machines creating art. Now, whether you like this or not is a question, but then if you think some of this is crap, there's lots of human art that's also crap. So the question is whether there's generally an advantage of one over the other. But I think most people would look at this and say, well, clearly that's art in the way we think of art. Ray Kurzweil, who's head of engineering at Google, wrote a book called The Singularity is Near. That's the point at which computers will be capable of all the things that humans are capable of. He predicted when he wrote this book that by now the computers would be capable of the computational ability of a single human brain, and by mid-century, computers would be capable of the computational abilities of all human brains put together. This is all proving to be generally true. So what he predicted was by now, creative AI will be capable of making complex art and music. I just showed you examples of that. If you Google artificial AI and music, lots of really interesting stuff comes up. Within a decade, they'll be capable of autonomously learning and creating new knowledge. So without us asking them to learn, they will begin learning. Within a couple of decades, non-biological intelligence will be billions of times more capable than biological intelligence. And by mid-century, AI will surpass human beings as the smartest and most capable life form. So point of this is not to emphasize the technology, but within our industry, the people who dismiss AI as being capable of what architects and designers are capable of aren't really looking at the research, because the people who understand this say that it's only a matter of time. A couple of years ago, I had a series of articles about this topic in building design and construction, and we did a series of surveys of the readers of building design and construction. So it's a broad swath of the AEC industry. And some of the questions we asked were, do you feel that automation and AI are threats to job security in your field? 3/4 said no, and 1/4 said yes. So generally speaking, they felt that they were safe from automation. When we asked whether AI will ever match or exceed intelligence or creativity of humans, only 22% said yes, and yet I just showed you lots of examples of the experts saying that's totally false, that it's only a matter of time. Now, what's interesting is you look at the difference between architects and contractors, builders, very different. 81% of architects say that this will never happen, whereas only 63% of contractors say this. So there's a 20% gap in which one is closer to reality. I think builders are. So here's a question. If we tend to think of architecture as art and building as science. So, and left brain, right brain, call it what you will. One is more about implementation. The other one is about creativity. And you could see why people instinctively would think that one is harder to automate than the other. So if we think of architecture as an art, this is a very common understanding. Some of the most famous architects who've ever lived have defined architecture as art and nothing else. Fast forward to today, Santiago Calatrava says that architecture is an art, the most abstract art of them all, which begs the question, if architecture is art, what is art? Another elusive term like good design, but conventional wisdom around art is essentially that it's about self-expression. Strip away all the other details. Generally speaking, there's an understanding that art is really about self-expression. And again, lots of celebrated architects saying that that's exactly what architecture should be about. Frank Gehry has said to deny the validity of self-expression is akin to not believing in democracy. Democracy is the will of the majority, not the will of the individual. So I don't know whether Frank Gehry needs a civics lesson, but the point of this is that we tend to think of architecture as an art. Art is defined as self-expression. You have lots of architects who are saying that's exactly what architecture should be. So I read when I had a column in Huffington Post, wrote an article about this with the headline, "Why Architecture is an Art and Shouldn't Be." And I got a lot of heat for this. This idea that architecture is art is so embedded in our thinking about what our field should be about, that the very idea that it might not be that leads to some pretty extreme reactions. A design journalist I like and respect a lot said, when I posted this on social media, she replied, "Claptrap." And I got a lot of reader comments calling me a psychopath and that sort of thing. So my friend asked me, well, if architecture is an art, what is it? And I said, well, I don't know that we need to compare it to another field. We can just define it on its own terms. But if we're forced to compare it to another field and we think of our art and science as a dichotomy, which I think is false, then what would happen if we thought of design primarily as a science and we really look more at the outcome of it? So if you think about a scientific method of design, we set out to accomplish something. We do research to develop the smartest strategies to accomplish that, and then we measure the results. That sounds like a far more promising approach to design in an age where design is wrestling with unprecedented challenges than to think of design as an opportunity for architects to express themselves. So if you think about this question of art versus science, E.O. Wilson in the book Consilience says that the idea that art and science are fundamentally different things is a modern conceit. It goes back to Descartes. Before that, people understood that the two were integrated. And in fact, E.O. Wilson says that our relationship with the earth, meaning the kinds of challenges that we're wrestling with under the rubric of sustainability, were fundamentally created when we separated these fields of thinking. And until we bring them back together, our relationship with the earth will remain problematic. It's this kind of thing that led to me writing my book, The Shape of Green, which came out in 2012. It's the first book to look at how to bridge the gap between standards of good design and standards of green design. We still think of design as an art and sustainability as a science, and how do we merge them in the way that E.O. Wilson is describing? A lot of the book is about emerging research in neuroscience and environmental psychology about how different shapes, colors, patterns, textures, etc., space and our relationship to it can lead to certain kinds of physiological and mental and emotional benefits. Some of it is ancient. The ancient Greeks understood these kinds of proportions and the effects that they had on us. If you apply that to a lot of science into beauty today, it's really just about mathematical distances or ratios. It's about proportions. That's geometry. Geometry is math. Math is what computers do really well. So when people ask whether computers are capable of creativity, really what they're asking is, can computers create beauty in the way that humans respond to beauty? If beauty is about geometry and proportions and that's math, then computers can do it well and will probably do it increasingly well. A subtler form of this, if you look into the kinds of things that we respond to in natural systems, there's something called natural fractals, which is something that is self-similar at various scales. If you look at this tree at 3 different scales, it looks similar. artificial fractals, computer-generated fractals, the kinds of things that Benoit Mandelbrot made famous in the 80s with the book Chaos. That's very different. They look like computer-generated paisleys. They're identical at every scale. So they look kind of artificial and mechanical. Natural fractals have this sort of self-similarity that I think that makes them more structurally resilient. You see this all throughout nature. Coastlines, lightning bolts, clouds. It's complex geometry rendered through math. Mathematicians and scientists classify natural fractals on a range of 1 to 2. 1 is completely open, so there's virtually nothing. If you think about being in the Sahara Desert or out in the open ocean, that's a fractal of 1. 2 is complete density, so it's darkness. Somewhere in the middle, this range of 1.3 to 1.4, there have been studies using skin conductance tests and heart rate monitors that show that just by being exposed to fractals with the optimal density, just by having it in our field of vision, it can lower stress by as much as 60%. These same studies looked at Jackson Pollock at his mature work in 1949, which is the year that Life magazine called Pollock the greatest living American painter, and found that these canvases conform to this optimal fractal density. And the theory is that Pollock spent years slinging drips and drabs of paint onto canvas to excavate this sort of shared memory we all have of this kind of fractal density that we learn from our evolutionary history, which I'll show you in a second. So it's interesting to think of if Life magazine called Pollock the greatest, most important living American artist, and we can identify exactly what makes us respond to this as great art, meaning that it's certain proportions, geometry, optimal fractal densities. That's something that can easily be replicated by computers and take far less time than it took Pollock to get to this mature stage in his work. So if you take that idea and apply it to architecture, here's a study that a team and I did looking at how we can take advantage of this in the built environment. We called it refractal. It's the idea of a facade that is drawing from this kind of research and applying it to workplace stress. So if natural fractals, just by being in your field of vision, can lower stress, then what would happen if we applied that to the workplace? This is an epidemic, essentially, of workplace stress. And if you applied this idea, it would say that the annual cost of stress-related ailments in the workplace is estimated at $500 billion a year, and you can reduce stress by 60% or reduce the incidence of stress by 60%, then the potential value of that is $300 billion by avoiding these kinds of healthcare costs. So the question is this: we know from increasing numbers of studies that in the workplace, daylight and connection to the outdoors are very important for health, wellness, and productivity. Now, we can control daylight to some degree, but we can't always control the nature of the view. This is considered an excellent view. This is considered a pretty bad view. So how do we make this feel more like that in a setting where we can't control whether there's a forest outside your window? So the idea of this study was that you could take natural fractal densities and apply them to a facade and shade it, but also bounce light around and frame a view, but also relieve stress in the way we were describing. So we came up with this script that would automate this. So imagine this rectangle being an entire facade or a window or an entire length of a single floor in a facade, and you could automatically apply these natural fractal densities to them in a variety of different kinds of patterns. When we applied this three-dimensionally to a whole building and adjusted its depth in some ways, we found we could reach spatial daylight autonomy just by using this to bounce light around. So it has a double effect, of beneficial effect. Point of all this is that, we tend to think of beauty as being in the eyes of the beholder, but it's something we increasingly understand scientifically, mathematically, that we can be able to replicate it with computers. So the thing that people like Daniel Davis dismiss computers being able to do in our field, which is be creative, we're finding it's just not true. Those kinds of things. In fact, this research applied through automated systems can more easily, more predictably get to patterns and systems that we perceive to be beautiful than we can as humans just through trial and error. So the basic question I would ask is, design really need a designer? We look at something like Thorn Crown Chapel in Arkansas. I've been there. It's one of the most astounding buildings I've ever been in. It's incredibly beautiful. But then if we ask ourselves, if this is something that we consider to be the height of production among architects' creativity, and then we look into a place like this, can we really say that this is better than this? Can we really say that if creativity is the exclusive realm of humans, then how did this come about? Unless you subscribe to a theological point of view, this came about randomly, evolutionarily through genetic coding and certain environmental forces such as sun and wind and temperature, etc. Oh, that is loud. I don't know if can you guys hear that? I'm going to get through this quickly. So I forgot there was sound in this. So if you look at these kinds of things, it's incredibly beautiful. But again, this is just coding. It's the equivalent of that fractal facade applied with a kind of algorithm, right? It's just genetic coding taught to do this over a long period of time. Lots of scientists and others are studying this kind of thing, automated assembly, where it's just using natural forces to take on certain shapes. And when you look at something like an aspen grove, which is incredibly beautiful, and natural systems without human creativity tend to create things that we find astoundingly beautiful. And then by and large, increasingly, what we put into nature looks more and more like this. So are we really so arrogant to say that only humans are capable of creativity? Architecture is an art, and therefore the built environment, it is the exclusive realm of humans to shape. I don't know. So especially when we're facing unprecedented challenges that we have never thought of before. Now, we all know that climate change is one of the most profound risks that we have today. And conventional wisdom says that the factories and cars are the challenge, but all the numbers show that buildings have the lion's share of carbon emissions, nearly half, depending on the numbers, the source of the numbers you use. The AIA over the last decade or so has collected numbers from architects looking at, the degree to which we are able to decrease energy use and carbon emissions. And we've set targets that are pretty ambitious, and year over year, we're coming nowhere near them. So we are really behind in trying to address this challenge, and architects really should be leading this, because if buildings are the culprit and architects are leading the building industry, then why aren't we getting better at this? My theory is that because we tend to think of architecture as an art, it's really less about applying science to these challenges than it is about, we're going to design things we like, and then we'll maybe pay more money for a mechanical system to make up for the art that we're perpetrating on the world. So if you return to this survey, then a question here is, one of the questions we asked our readers is, do you feel that automation could actually help create better buildings? 83% said yes. But when we asked if AI and automation is proven to create better buildings, do you feel that it would justify potential job loss? And people were torn. So 83% say computers are actually capable of creating better buildings than humans, or will be eventually. But when we asked whether that meant that it justified people losing their jobs, they're not so sure, which begs a really huge question I'll end on. Which is more important, architects or architecture? Thank you. Anybody still there? I lose you?
No, we're here. So I'm going to take over here This is a great talk, Lance. This is
Thank you.
definitely very thought-provoking in different realms of the architecture domain. So I'd like to open this to a conversation just to help the audience better understand your viewpoints in general. So I want to start with the last question that you rhetorically asked. Which one is more important? Is it architects or architecture for you?
For me,
Mm-hmm.
I think I'll start with the idea that the built environment is profoundly important because I just showed you it's the lion's share of carbon emissions. So the effect it has on climate change, and which also affects public health because we know more and more about the relationships between greenhouse gas emissions and respiratory ailments such as asthma. But it also has a big effect on other living systems. But we also know that people spend 90% of their time indoors, and over the last decade or so, for the first time in human history, more people live in cities than don't live in cities. So even in that 10% of the time when we're not indoors, we're surrounded by buildings. So socially, buildings are the backdrop of our lives. And then finally, economically, it's been estimated that the building sector accounts for nearly 40% of global GDP every year. And yet, by and large, designers and architects are not really trained in the economic impact of our work. So socially, economically, and environmentally, the built environment has a profound impact. So therefore, I think the built environment is incredibly important. And I think that designers and architects should think of ourselves as shepherds of that, trying to get the built environment to improve its impact, be a force for good. And if we don't put that ahead of our own personal desires, then I don't know what our industry stands for anymore. So.
Mm-hmm. Mm-hmm. Great. Yeah, I completely agree with you in terms of the impact. This is well documented in terms of the impact of the built environment on the human being and their health. So just to bring the conversation into the AI, robotics, and the different viewpoints that we see between experts versus the architects. So it was interesting and it was quite striking to see the differences between these viewpoints. Like experts believe that it's possible with a large percentage that architects can be replaced, but the architects think that the chances are very slim. You gave those statistics based on the BDC survey as well, that this same gap we can see between the belief that AI can design better buildings, right, with the vast majority, and then the belief that it cannot result in job loss. Do you have any thoughts? What could be the contributors of such a large gap or perception in our industry? For example, we have been talking about our industry has always had this slow pace of innovation acceptance or adoption. Could this be one of the reasons?
Yeah, it's interesting. If you're familiar with Hunter Levins, who was one of the co-authors of the book Natural Capitalism,
right.
She says the construction industry is dynamically conservative, meaning it works hard to stay in the same place. And I'm fond of looking at other industries and how they have changed over time. The most common car on the road, the last time I looked this up, is the Ford Fusion. It's a little sedan. And it looks dramatically different than the Ford Model T a century ago because there have been innovation after innovation after innovation. Other than the fact that it has 4 rubber tires, it's essentially a different animal, right? The most common plane in the sky, I believe, is a Boeing 737, which looks radically different than the Wright Flyer 100 years ago. If you look at a typical house today, a wood frame house, platform frame house, it looks essentially the same as it did in the 1860s. So what does that tell you about the kind of progress we're making? And then look at the components of that. I give a different talk. This is something that I look at in my book. that virtually, most buildings you would walk into are made of wood, steel, or concrete. And all three of those systems, virtually every building ever built, uses about 40% more material in its structure than it needs to. And the reason is because if you look at, if sometimes in talks I show a moment diagram, and which we all learned in structures, which is just a diagram of how forces move through, say, a beam. And when I show that, I see architects' faces go pale because they're having a Pavlovian response to structures classes from architecture school and losing sleep. But essentially, if you look at a moment diagram from point A to point B with a beam spanning a certain length, it's fluid. It's sort of narrower at the ends and deeper in the middle. And what we end up doing structurally is we say, all right, it needs to be yay deep at this point. So we'll make it yay deep across the entire length of the beam. So you take the worst case scenario where you need a certain amount of depth of material and extrude that across the entire length. We do that in wood, steel, and concrete. But if you look at a tree, a branch is not a giant rectangle, right? It puts material only where it's needed. So living systems which don't require humans for creativity are much smarter than we are at adapting. They're just very slow. Mm-hmm. We're not even trying, really. There have been really interesting studies, which I can drop a link in the chat bar, of looking at concrete, which is more fluid. Mm-hmm. You can put concrete only where it's needed by using formwork that is more malleable, like a sew it like a dress textile formworks. And suddenly you can start to imagine buildings evolving to become more like skeletons or trees or reeds on a riverbed. Mm-hmm. I think the reason why architects are slow to innovate is because we think of ourselves, again, as artists. And if it's really just about expressing myself, any architect who went to architecture school, it certainly was taught that the way that you mature as a designer is to develop your own voice. If your work looks just like your colleagues' work, then you're doing something wrong. But they might be equally good solutions. And but if we think that we have to cultivate this unique point of view, then we're going to miss an opportunity to innovate. There's a slide I show when I give a talk about my book that says one of the most coveted things in the culture of design is the so-called signature style. People hire Frank Gehry because they know they're going to get the sort of melting potato chip look. Yet if you know in advance that something is going to look and feel in a certain way, then you rob it of an opportunity to evolve to become whatever it needs to become in those circumstances, these people in this place with this purpose. So as a result, the signature style is arguably the single greatest obstacle to sustainable performance, even while it might be the most coveted thing in architecture. So until we completely shift our thinking about the purpose of design, we're never going to get anywhere near where we need to, which is why I think you see that rough flat line over the last decade of architects trying to reduce carbon emissions. I think this is related to a comment that was made in the chat bar, so I just want to address that quickly. The idea that if computers took over the creative process, the cities would all start to look alike. False. So if you look into nature and you go to the Sierras and you go to the Costa Rican rainforest, or you go to the Black Forest of Germany, they don't all look alike because they have different climates, different habitats, different availability of types of materials. Same thing would happen if you automate the creative process, because in fact, I think places would start to look more distinct from one another than they do when architects or developers get their hands on it. I just showed you the image of production housing, suburban sprawl. That could be anywhere. Mm-hmm. It's the same in urban settings. You increasingly see cities with generic glass box towers or mid-rises, and it could be anywhere. When I live in San Diego, when I first moved to San Diego, there were all these new mid-rise multifamily residential towers, and I thought they look a lot like Vancouver, where I had just visited. Someone pointed out they're the same developers. So it doesn't matter where you go. If humans get their hands on it, they tend to default to the same things. I actually think if we allowed the process to automate itself and become what it needs to become in different places, we'd start to see more distinction between places. Does that make sense?
Yeah, definitely. I mean, you have been touching to different aspects of design when you were even responding to the comment in the chat box. So there are certain things, and in the conversation, the talk that you have been talking about things that could be automated, right? Looking from a scientific perspective, where we need to think, what are the metrics? How do we evaluate our design? These, to me, are in the form of like, there are certain behaviors that are expected from, say, from a sustainability perspective. There is the intent, there is the functionality of that building, but there's also the form. Do you think can AI automate all these aspects, or there are certain things that would require different parameters in the design, and AI never can automate that?
Well, first of all, I'll say again that I'm not a technology expert, and I know very little about it. All I know from my research is that eventually we're likely to get there. Eventually, the computers will be able to do anything that humans do. That's what I'm told. Now, how long it takes and whether it happens in exactly the same way is a different question. Right now, I can't think of anything that architects bring to the table that isn't theoretically possible of being automated, and maybe in ways that speed up the process, make it a better outcome that's more efficient and more affordable. But my question really is more, what is it that we're afraid of? I mean, virtually, if you, by and large, anything, I think it's true that I haven't looked at this in a while, but the relatively few articles that have been written by architects about this question, can building design automate itself completely? I think I might be the only architect who said the answer is probably yes, and that's a good thing. Most are saying, even if it could, it's not a good thing. Most are saying it's never going to happen. And the ones who are saying it might happen are saying it's a bad thing. I've yet to encounter anyone who said it might possibly be a good thing. So my question is, what are we afraid of? Why is it such a scary prospect that the thing we do when we put pencil to paper could happen without us putting pencil to paper? I don't know why that's such a scary prospect, unless, and I really don't think it's about job loss. I really think it's more about this fundamental sense that I became an architect because I thought it was about me playing artist. And when you rob me of that poetic license because it's happening in some other way, that is fundamentally threatening to me and my value system. If we are taught that great architecture is Frank Lloyd Wright, then this idea is going to threaten to us. If we're taught instead that the built environment is a profoundly important, impactful thing, and it's a sacred duty of ours to try to make the built environment better and better for people and other living systems, of course we would want to embrace everything we could to fulfill that promise, right? So I think it's a fundamental difference between what is the purpose of architecture? Is it to fulfill our personal desires, or is it to try to make the built environment a better place? I'm hoping it's that second thing, but I don't know that people are really doing enough soul searching to figure that out. And that's why I think we're seeing lots of contradictions in these surveys.
But I just, what you just said, just intrigued some thoughts in my mind. Does it have to be one versus the other? They could go hand in hand. I'm trying to understand if maybe the architects and the professionals doesn't know the technology and its capabilities and how to get there from a technology perspective, but also it doesn't necessarily have to be replacement. There could be a version where the AI can co-work with the architect. So there could be and assistance that we receive from the AI. And it was the same thing that we were experiencing when cost estimators were looking into, okay, can automated quantity takeoff and building information models, when they're used for cost estimating, could replace estimating, right? So model-based estimating doesn't necessarily replace cost estimating because there are value-adding tasks and non-value-adding tasks. So if you help with the automation to remove the plates and then get all the non-value-adding tasks, cost estimator job is looking into the pricing, right? Get the right pricing to get that. So it could be the same thing that some of the things could be automated through AI, and then the other aspects of things that we expect the architect to provide could be coming from the human workers. So I'm thinking that there could be a balance between the two.
So I mean, I agree. My premise is really not, will architects cease to exist as a profession? It's really more, how do we make the product of our work as good as possible? And what is the purpose of our work? And if the purpose of our work is for the built environment to be as good as possible, then we should embrace every strategy we can to do that. And if the possibility of fully automating the design process is there and can lead to a significantly better outcome than we can do without that, why wouldn't we not embrace that, even if it just slightly changes our role in the process? Right. Which is, I think, what you're saying, right?
Mm-hmm. Exactly. So one of the challenges that I'm also seeing in the industry is for AI to learn, you have to have a lot of data. So I'm talking from the technology perspective. I know that you are saying, okay, what if it's there? And let's look at it from that perspective. But from a technology perspective, because I'm the one who is on that side, looking into how to develop AI for generative design, can we come up with these design using machine learning algorithms? One of the important parameters here is the quality of the data that we're receiving, and then the quantity of the data that we use for training those AI models. We are currently leading a project looking into modular construction and trying to come up with these design, generative design, just from the perspective of volumetric units. And one of the things that I'm seeing in the industry is sharing of data and thinking about the ownership of data that will eventually be utilized as a training data set. What are your viewpoints in, if you were to look at the industry from a different perspective and have AI part of this ecosystem, what are the things that we can do, maybe through AIA and other organizations, to help firms to start sharing their design portfolios or historical design projects, even at a smaller scale? What is the hesitance that we're seeing here, and how can we overcome? Any thoughts on those?
I'm not sure I completely followed your question, but if I think it was about how we can get architecture firms to share more information. So we'll go back to the 2030 commitment, AIA. So right now, I'd have to look up the numbers, but I think there is something like 500 signatories, and maybe half those submit actual data every year.
Right.
So even the people who have said, I'm committed to doing this, only about half of them, maybe a little more, actually follow through on submitting data. No one knows how many architecture firms there are in the US, but I've seen estimates that there are as many as 20,000. So you're getting 500 people out of 20,000, 500 firms out of 20,000 saying this is important, and half of those are actually sharing data. So that's a tiny fraction of 1% of all architects have said, I'm committed to this. Within the data, because I've been, I've talked to or been in many of the firms that submit this data, I know that a lot of the data is probably mostly inaccurate. You can also see that it's all often rounded up. So if someone says, oh, it's, if you see that square footage of all these buildings is exactly 100,000 square feet or 30,000 square feet, somebody's rounding up or down. So already you're getting something slightly off. and look at the snowball effect of that over billions of square feet, we have no idea whether that information is accurate. Now, apply to that the level of inaccuracy of even predicting energy performance in a building. And there have been studies that have shown that, with the modeling that we use today, even LEED platinum buildings, there is many buildings that perform better than anticipated as perform worse, to the point where there are LEED platinum buildings that don't even meet energy code, right? So we have no clue whether any of this is accurate. The only way, you would know better than I do, given your area of expertise, the only way to get accuracy is to get more and more data and look at it in certain ways. So the dream would be that every architect or builder, every building that is designed, there's an automated process that evaluates its energy performance and then shares that data. So we're seeing everything, and we're seeing it with a finer degree of accuracy. I think we would very easily be able to see where the challenges are. So if you had a huge volume of data that you had a certain degree of accuracy about, then you could see, all we have to do is change the window to wall ratio in every building by 3 percentage points, and we cut 30% out of the energy consumption of the entire American building portfolio. Without that kind of information, it's kind of a shot in the dark, right?
Right. Yeah.
I don't know, but I think if your point is how do we get people to share more, I don't know why we think our information is proprietary. For instance, even the 2030 program, of the 300 or so firms that submit, you're not seeing who submitted why. You're just seeing the overall average. And the interesting thing is, I believe the original purpose of that program was to show how the industry is progressing. But very large firms, so keep in mind that AI defines a large firm as 100 people or more on staff. There are firms with thousands of people, but the 100 or more represent, I think, fewer than 3% of all architecture firms, but they're responsible for something like 30% of annual billings. If you look at the very large firms with thousands of people, the amount of data they're submitting every year, the amount of square footage, the volume of work they're submitting to 2030 is the vast majority of data. So what you're seeing every year in that chart I showed is maybe 3, 4, 5 firms represent 85% of that data. So what was meant to be a cross-section of the whole industry is actually a snapshot of a few very large firms. So, and yet we're not seeing that, and AI is not revealing that. So we really have no clue where the sticking points are.
I see. Okay.
So, Semiha, I'd like to touch on a question. Lance, I think you saw it, but just for the benefit of the audience, this is from Marku Allison. I've always thought a future where architects thought of themselves more as designers of design than simply designers of objects could have a great benefit for all, which I completely agree with. So my reinterpreted question, when buildings can design themselves, how will architects redesign the impact to what they could have on the built environment, and what questions can we answer?
Yeah, it's a great question. See the little thumbs up emoji. That was my reaction to Mark's statement, because I completely agree with that too. So if you think about, what happened to buggy whip manufacturers when cars became more prevalent, they didn't just stop working; they transformed to some degree. If you look at all the major oil companies, they're all investing heavily in solar, because they're seeing the future. We're talking about the same thing here. If we think of ourselves as designers of design instead of designers of objects, it just means that we slightly rethink what we're doing. And that's already happening. If we are trained in architecture school to think that, I had a conversation with a friend recently where let's face it, my impression, right or wrong, and this might be fairly cynical on my part, is, on the one hand, I think of myself as a fairly happy architect. I'm pretty fulfilled in this profession because I went into this profession when I was a teenager, decided to become an architect, largely because I think our generation, Zig, was the first to be told en masse, you could be anything. My parents grew up on a farm, as did their parents and their parents and their parents and their parents. And the expectation would be they would stay on the farm and keep moving the plow around, right? So they were not told you could be anything you want. Now kids are all told you could be anything. And yet I think it kind of backfired because there's a certain degree of anxiety of, well, if I can be anything, how do I choose the one thing? Because there's this expectation that you're a butcher, baker, candlestick maker, not all at once. Go back to that study that says if you can explain your job easily, it can be automated. Well, if you can't explain your job easily, meaning it's unique, then it can't be automated. So architecture struck me as one of the more familiar professions where you could literally do anything and call yourself an architect. It's creative, it's technical, it's artistic, it's scientific, and it has proven to be that. I love the variety of it. My dad was a CPA and pre-Excel sheets. When I was a kid, in the early days of his practice, he would have an adding machine and a pile of receipts on the kitchen table every night, and he would just like punch the adding machine, and I'd hear that zzz sound, and I thought, I don't know what I'm going to be, but it's not that, because it was just the same thing over and over again. So but the conversation the friend and I had recently was, in architecture school, you spend 90% of your time designing, developing concepts, and maybe 10% of your time doing other things. You get out of school and it's exactly reversed. You spend maybe 10% of your time designing and 90% of your time doing other things. That's true even if your primary role is design. And within firms, generally speaking, I think this is a fundamental challenge with our profession. Design is filtered through very few people instead of sort of distributed in a collaborative way. So the people whose jobs might actually be threatened to some degree with change or removal are very few architects, because they're the people who think their job is just to shape things in some creative way. And most of us actually, I'm fortunate enough that I get to do that now and then, but I like to do it collaboratively. And I think most of the profession is just thinking about how can I make this as good as possible. So not much of a shift that would happen if architects are redefined in the way that Mark is describing.
Okay, great. Semiha, we probably have time for one more question. Did you have any others?
Just one question in terms
Sure.
of given that, as you were saying, Vance was saying in the presentation, it's a matter of time that AI will be with us. How do you think your talk will be different next year or maybe in a decade from now?
Well, the thing is, so I started to develop this talk a few years ago for a particular event, and I am not staying abreast of the latest developments technologically. So if I gave this talk again next year, the premise of it would probably be the same. How can we make the built environment as good as possible, and what's our sacred responsibility to help do that? But the examples might change because I think there are better and better examples. But the experts I do know within our profession, at least once a year, I ask them, is anyone developing a fully automated design, a building that is designed without us thinking in advance, I want it to look a certain way? And I've yet to come across that, which it strikes me as a gigantic opportunity for innovation. I don't think it's because we're not capable of doing that or nearly capable of doing that. I think it's just because we don't want to do that, because we think that it's just not on our radar, right? So I don't know that the fundamental message here would change no matter when I gave this talk, but the examples and the degree to which we can actually explore this are changing all the time.
Okay, this concludes CIDCI's online salon. This session will be placed on the CIDCI website as soon as possible. To join us for future webinars, be sure to subscribe to our newsletter on our website, CIDCI.org. Special thanks to Katie Olson for keeping us on track and for our sponsors who make this all possible. Thank you for joining us as always. If you have any thoughts or comments, please reach out to us via the CIDCI website or click on the Contact Us link. Thank you and have a great day.